Influenza, the common cold, and other respiratory infections show seasonal transmission that coincides with changes in temperature, humidity, and solar radiation. But seasonal epidemics are also a product of the transmissibility of a virus, the initial susceptibility of a population, and the degree and nature of immunity conferred by infections. In this video, we investigate which weather conditions are most associated with COVID-19 cases. There are good reasons to expect a respiratory virus to show seasonal variation. Infections with influenza and respiratory syncytial virus are more common during winter in temperate areas of the world. Studies of the first SARS coronavirus in 2003 suggest weather might be important for coronavirus spread. While this virus did not circulate long enough to establish any potential season pattern, daily weather was associated with a number of cases. In Hong Kong, new cases were under 18 times higher and lower temperatures, under 24.6 degrees Celsius or 76 Fahrenheit, than more elevated temperatures. The epidemic died out during a warm, dry July in 2003, but tight public health control measures were also in place. In cold and drier conditions, the mucus lining in our noses dries up, which in turn impairs the function of cilia, the tiny hairs that line the nasal passage. These beat less often, meaning they may fail to clear viruses from the nose. The review concludes that a relative humidity of 40 to 60% might be ideal for respiratory health. Research led by the University of Texas at Austin is adding some clarity on weather's role in COVID-19 infection, stating that transmission of COVID-19 from one person to the next depends almost entirely on human behavior. In terms of relative importance, weather is one of the last parameters. When it is compared with other factors using a statistical metric that breaks down the relative contribution of each factor toward a particular outcome, the weather's relative importance at the county scale was less than 3%, with no indication that a specific type of weather promoted spread over another. Taking trips and spending time away from home were the top two contributing factors to COVID-19 growth, with a relative importance of about 34% to 26%, respectively. Americans spend 87% of their time indoors. So how does the outside weather affect them so much? When cold dry air meets warm air from indoors, it reduces the air's humidity inside by up to 20%. During winter, indoor humidity levels are 10 to 40%, compared to 40 to 60% in fall and spring. The lower humidity aids the spread of virus aerosols and can make the virus more stable. However, a study of 17 cities in China with more than 50 cases of coronavirus found a link between rises in humidity and reductions in COVID-19 cases. The team measured humidity as absolute humidity, or the total amount of water in the air. For every gram per cubic meter increase in absolute humidity, there is a 67% reduction in COVID-19 cases after a lag of 14 days between the humidity increase and the number of cases. Brazilian researchers looked at rainfall worldwide and confirmed COVID-19 cases also increased with greater precipitation. For each average per day of rain, there is an average of 56 COVID-19 cases per day. No association was found between rainfall and COVID-19 deaths, however. SARS-CoV-2 virus is highly stable outside the body at 39.2 degrees Fahrenheit, but increasingly unstable at temperatures above 98.6 degrees Fahrenheit. A study in Spain found after 5 days of lockdown, the longer the hours of sunshine, the more cases were of COVID-19. This positive association held true with the lag between sunshine hours and cases of 8 and 11 days. There is no link between the hours of sunshine before lockdown and during the first 5 days. With all this being said, no human settled area in the world is protected from COVID-19 transmission by virtue of weather at any point in the year. Many scientists expect COVID-19 to become seasonal in the long term and conditional on a significant level of immunity, but that condition may be unmet in some regions, depending on the success of outbreak containment. All pharmaceutical and non-pharmaceutical interventions are currently believed to have a stronger impact on transmission over space and time than any environmental driver, which has little to no effects. Thank you for staying along with our video. We know it'll be a long season to come, but we hope you all stay safe.